Okay.
Yeah.
All right. Hello, everyone. My name is Joseph, and today I will talk about this paper, a blockchain use case in food distribution. Do you know where your food has been? So let's see how it goes. Oh, okay. So the agenda about this paper is about the abstract, the background, the methodology, the results, and the findings and discussion and conclusions. Okay. So first, I will talk about the abstract. I mean, the research question is how blockchains can be utilized and applied to more accurately and transparently move goods through global supply chain. So the paper is talking about, I think some farmers, they want to do the best, I mean, the best tool. They want to use the best tool or the best way to transport their eggs, do some packing like in the picture. As you can see here, this is a basic, this is an example. I just found it in the net. Just they want to just to move. I mean, they do the process of the packing, like grinding, distribution, the retailers and the food manufacturers go to the consumers, go to the fast food like McDonald's or KFC, and most of the egg farmers produce the kind of the. They also produce the egg, shells eggs for the sellings. All right. So the main purpose of the abstract is just to find how to move the goods through the global supply. I mean, from the farm to the final customer. All right. So in the paper, they talk about some tools like IoT, Internet of Things, and blockchain. I'm not sure if you are familiar with this, but let me explain you a little bit more details for each of them. The tracking system will be a combination of both IoT and blockchain. All right. So what is it? I mean, what is exactly blockchain? Okay. In Chinese is Qi Kuang Lian. Okay. Um, okay. It is a type of database. What is a database? Database is just it's a collection of information stored in tables. Very easy, very simple. All right. Many tables together become a database. But what is the difference with an Excel spreadsheet and store information rather than the database? Well, you can see maybe, oh, Joseph, you have the tables also in the Excel file. Is it a database? No, because the data stored in the Excel sheet could be modified, could be formatting here, but in the database cannot. It has kind of consistency. That's why I mean for the different apps, different APIs, different interface, they need to be managed by the database management system to grant access to the database. That's why there are many companies like Oracle, MySQL, Microsoft SQL to get the management of the system and grant access to the database. So what is the blockchain again? I mean, the database structure is a data in the tables, right? But I mean, not. I mean, the blockchains are databases, but not all databases are blockchains. Why? As you can see in the picture here, the blockchain is a collection, but not about tables. It's a collection of groups. All the information going in each group is a specific different approach of information. That's why, for example, in the first picture I show you here, that block change can be included in different blocks. That's why they call block change. They have a block after another. For different user, you have a different block. So in each block, you have, for example, the set of information for valid transaction. You have four kind of, for example, here you have the hash, the root, the timestamp for each of the transaction. How it works? It's very easy. Just, I mean, it will be in the timeline. You have the first transaction, you get some hash, the value of the money, for example. Hash is just a value. And you have the hash, for example, you have the money, or maybe you have the password, 1234. And for the transaction two, the password also will move to the next block, like a history. Your money and your password will belongs to the next transaction, so you will keep on session in the blockchain. After you finish the transaction, this hash will be equals to 0 and we'll reuse it again. That's a basic concept of blockchain. Why we need to do this? Because it's the only way you can get consistency. With your transaction, we don't want someone else to use your blocks. That's why one user is one block, and one system it will be many blocks, and one blockchain have a collection of blocks. All right. So basically, the idea of blockchains, it works like this: like some request transaction, they have the request transaction. For example, there is a famous blockchain in the market called Bitcoin, and they request a transaction in the broadcast for the P2P. No, P2P stands for connection peer-to-peer. Some different places for the connection. And they create a node. The peer-to-peer network nodes validate the transaction and users' status using some algorithms. And they create, for example, the first user will start the first block, and they will start continue to access to the other blocks. In the history. Those, this collection is about just one user, but each block is a different transaction. That's the idea of blockchain. So for cryptocurrency, they need to verify the transaction, right? They need to verify it, with some records and some information, and this kind of correlation, they need to be, for example, validated with some entities, some banks entities. They can also get or receive the transaction, for example, from the money, right? Some people say like in the future, maybe the banks won't be here because everything will be about blockchain, Bitcoin, but still there is a while for this, just to let you know. But about the paper case, it says some specific points for this case. For example, in supply chains, multiple cases have been analyzed to understand the impact of the blockchain technology. And the key supply chain objectives such as cost, quality, transparency, trust, risk reduction, sustainability, and flexibility. So this is the key. That's what the owners of the farm they want to find: reduce the cost, quality, transparency, etc. So they believe that blockchain usage enables organizations to protect sensitive information and eliminates institutional intermediaries. It analyzes and identifies boundary conditions to sharing audience information to improve traceability. I will talk about this later, traceability. In the article, also the author present a use case for egg distribution company and the blockchain lab in the Middle West, in the Middle Western region of the United States. Okay, so we have the methodology here. For this case, the study of the author takes the Bytable Inc. This is a real application. You can Google it and you will find it. The name is Bytable Inc. In the beginning, it was a pilot project to track the eggs from the farm to consumers. So consumers are able to scan the QR code and each product package. The egg package, they have a QR code. So in that case, they can use this very useful POC, which is the proof of concept. Which can plan to bring the results. From the product to the market. They will just try to show you. How will be the pilot test results. The proof of concept, they will show you some results from the pilot test. This project, began in 2018, but they said in the market they will be in 2020, so it's already available. So about a pilot test, what they want to see in this POC, the POC in the pilot test, the proof of concept, they want to see, the traceability of the software. They find a sample of 100 small farms, like doing the cleaning, the processing, the grading, the packing, and the distribution. 100,000 eggs to retailers per week. They want to see the performance of each of a stage to see the traceability. What is the traceability? It's just the data collection of human and manufacturing process. We can see in each of them how is the integration of the human and the machine or the products you need to go each of them in order to deliver the 100,000 eggs for the retailers. per week. All right.
Yeah.
Here is like, for example, the table one, they have some data about the important use criteria. They have some considerations, like many considerations were taken in the execution of the use case and were relevant to determine how the solution was implemented. Some feasibilities, operation compatibilities, performance, privacy, and assurance. Especially for assurance, you have the data integrity. Data integrity means that that data, besides each of the steps, should be reliable, shouldn't be changed
Yeah.
or altered.
Mm.
While improving operational efficiency with product tracking, Table 1 provides a summary of the important criteria in the user case. It can be applied to any context and not limited to any food distribution. I mean, they not only, I mean, they start with egg, but I mean, they're planning to do maybe with other products too. So also you can see in the paper, I mean, the target model. I mean, they have, this is the ideal they want to achieve. For
Yeah.
example, they have the distributed ledger of traceability software. Just I told you what is traceability. For the
Mm.
packer traceability software to consumers to label state. And they try to find here, for example, some collection of farms. They want to call all the farmers maybe to get the big quantity and to key in the computer, put it online, and maybe just distribute the farm. I mean, the the package distributed from the farm X to the transit and then to the packers. And in the way you can find some packer staff, some people will be in charge of the transaction and the transportation, the logistics. Even so, then they will get some certification records, maybe some well, food certificates maybe they may need. And then we have the transit and the retailers, and finally they will arrive to the consumer. Consumer. And that's the idea of the target model for the system they want to achieve. So for the proof of concept, I mean the POC, I mean built to track data about the free range eggs which were collected at a variable number of farms and followed through the packaging operation and packing facilities. Eggs were collected from refrigerators located on the farm that transport the packing facilities to the store, washed, graded, packed, and shipped to the retail stores across the country. The goal of this proof of concept was to capture as much data from this process as possible and gauge its usefulness to both the business and the consumers. That's we see in the figure number 2, the architecture. This is the architecture they want to say. For example, the Hyperledger's sawtooth network, they call it like this. This is the name they put it. It's just a concept of the server. Then we have the validator Docker, the reset API, the interface, and some
Yeah.
transaction processes. Well,
Mm.
I'm not sure if I should explain you this, but, but maybe just briefly, just to mention it, they will combine, I mean, the servers for each kind of validators, and then we can buy also some microservices. I mean, they not only will use their own data, they will do some. I think it's kind of outsourcing because they will use other people's APIs, other people's interface. Maybe, for example, the IoT service, hardware software integrations, front-end apps. Why they mention IoT? Because I think they want to put some sensors in
Yeah.
some processes. I mean, in the transport, in the logistics, in the packing, in the grading. They want to measure each single step, as you see here in the traceability. In each of them, they will put some kind of measurements, some sensors, some IoT. They will connect with the servers in the architecture, and they will try to show some data in each way. Okay, so for the results and findings, I mean, the proof of concept began with the goal of 5 to 10% scan rates and average usage of 1 minute, both of which were exceeded by a significant margin. I mean, they want to see, I mean, how much they can get, I mean, the scan, I mean, around maybe 1 minute. And the proof of concept result in the above expected consumer engagement and interest in further development for stakeholders. As you can
Mm.
see, they did some proof also, I mean, not only in the United States, I think they also did in Europe. They also show in Europe some results, but I think they said they were not that suitable as they thought. They use, for example, the carton scan rate. They have, for example, unique site visitors. They have 46 around, which is represent the 21.2%, and they have the carton stick rate around the 78.8%, which is the comparison of the quantity of eggs carton sticker rate. I mean, to put it a sticker and the unique site visitors. I mean, they compare. I mean, about how many people visit. I mean, they can see the eggs in the visitor place on what is the quantity of people they prefer to use the scan. I mean, the carton way for the sticker. The use case applicability to Europe. As I mentioned it, they also did a POC in Europe, and this use case was originally planned to uh, imitate, I mean, certain aspects for the European system. But you know, for Europeans, they have also some different standards than Americans, so that's why they need to adapt. And to get some availability eggs, you need to wash it during the grinding process. Eggs marking prior to washing would be not feasible to making likely to wash it, or it could be not readable, no eligible. It means like in the I think in the European Union you need to wash, I mean, the eggs before to packing, before to put in the bag. That's why if they do the washing, maybe they cannot read some codes or some marks they will put in the bags or in the eggs also. They use some equipment and process constraints to make the marking individual egg. I mean, they want to do that in each of the egg. They want to make a mark. That implicates initial kind of maybe more difficult to do, no? Because they want to put it maybe in the box, which is would be more efficient. But I think the European Union, they have their own standards to need to do the washing for each egg.
Mhm.
Uh, Combining eggs marking with distributed ledger technology could be a sensible way to future traceability system to be implemented. Traceability down to the individual egg could be achieved more easily with unique markings and easy relevance. Okay, yeah, this is one of the paper proposed. They proposed to do kind of traceability systems also with this new restriction, but they didn't mention actually if it works or not. Okay, for the next one is that distributed ledger technology could also be a promising um, means of combating existing issues with market X system, like codes for grade records could be accessed more in for anywhere. I think to particular X marking unlikely to be affordable or incorrect. Okay. So this is the application interface. You can find it on the net and actually in Google you can find it. It's very easy. Just try to find it. I mean, you will see, for example, the code. Find the code for your carton. You will find it, and then you need to enter the following information in the bottom. You need to check, for example, the date, and you will start to trace my egg. You put a date because you want it. I mean, when you start to the tracking and when you finish the tracking. So you will put actually 2 dates in the system, and they will start to track. It's like, for example, you send a package in DHL or FedEx, something like that, but you will get the traceability. I mean, of the logistics from the beginning to the end. All right, and in the web app, I mean, you have some displays of the traceability X. Like, for example, they can see, for example, the features of the egg. For example, they have a free range egg of 12 eggs inside a box, and you can see, for example, what is the place? I mean, where is your egg in the maybe in the real way, or you can see, for example, some transit in farmers or some processing. I don't know. You can find kind of the DHL way, any tracking system. Where is your egg? Finally, they have also a farmer's interface, which also they can show you, for example, the farmer's background, their stories, some contact information, and what certifications they have for the eggs, the process, maybe FDA or something like that. Okay, and so discussions they have is about despite many challenges and barriers to overcome, The results indicates that consumers' demand and the seeds for improved traceability may drive to adoption between the certain segments of the food industry. The study also indicates certain environments blockchain implementations can be possible without immense effort from stakeholders. Well, the last one I think is probably true because in my opinion, I mean, it's like the blockchain usually is very automatic way. You just need to install it and to do some relevance from some entities to accept the transaction and you just can keep going, just like Bitcoin. So far, we don't have any regulatory company can regulate Bitcoin, for example. It's just free on the net. Some contributions we have, for example, this study was developed to understand the blockchain technology. Yeah, that's true. They explain a lot about the blockchain, the details, also about IoT as well. This is the first study. Now the author used blockchain technology to track eggs from farm to consumers in major markets in order to capture traceability and judgment data from the supply chain to the users. I mean, the key point, I mean, is to get or to empower the users, I mean, with all the data from the eggs. In that way, they can be more reliable for them. I mean, they can see, oh, my egg was maybe in which specific farm, in which specific place, and how long it takes from the farm to the consumer. Another contribution is the implementation method, highlighting that the studies such as the use of IoT sensors and integration into existing systems provides a framework for further studies to capture data and analytics related to the impact of their implementation. Yeah, as I said before, like IoT, you can find some new data and new kind of projections. Maybe you can see what is wrong or what you can fix in the logistics process. Some implication for practice also mentioned in the paper is that blockchain technology could be used in supplement food traceability on a new existing supply chain. I mean, not only, I mean, food, could be also any kind of retailer. I mean, adding blockchain technology is possible in practice, but scenarios exist where poor process and primitive technology exists among stakeholders. Usually we can say like this kind of technology can be used more in developed countries like US or Europe, but still there is a gap, I mean, between other countries, like they don't have the infrastructure for this. And we have the process distribution be required before the implementation of the blockchain. Yeah, actually, yes, the standardization, the process standardization, you need to have a standard way before to do the implementation of any technology. You need to do, for example, that we said the traceability way. I mean, the packing, the grinding, the washing, and the shipping of the process. You need to have already a standard way to do the things in order to improve each of the steps of the logistics. That's the only way you can use technology for adoption. Limitation on further research directions. This implementation is only, well, is early and there are still many limitation factors regarding the implementation of blockchain solutions for food supply chain. This study was performed with a specifically X brand in the United States with substantial internal traceability and data tracking. Yeah, I mean, in few words, I mean, it's like this just to show you the understanding of the blockchain. But as you can see in some point of the paper, they mentioned some limitation in the European Union, like they have some other standards to follow, like washing the egg and before to put it in the box, no, in the carton. There are no common interfaces or standards in regarding the food traceability. Yeah, that is true because every time a farmer want to integrate their farm to the change, they need to do their own interface to connect to the blockchain or to connect to the IoT maybe. They have some limitations regarding the ability to verify data. I mean, even though you use blockchain or IoT, still there is a limitation. I mean, to verify that those data because this is a closed system. When you have a closed system, you don't have someone who can supervise or can do some kind of double check of your data. I mean, sometimes even though it's something wrong in the transaction, and that the system can make the log and you can show that the result something was wrong, but you cannot fix it maybe because you need to do it. I mean, you need to do it again. All right. And
Okay.
some final conclusions we have here. This work furthers the research of conservation on how the blockchain can be utilized and applied to more accurately and transparently move goods through supply chains. In other words, it's just to show you how to move goods in a better way. And several opportunities for implement tracking methods and supply chain analytics were discovered during the implementation of new blockchain clients applications. Actually, in that way, they get more analytics, more data to be analyzed. And now the application is already available in the net, and you can see they have even now they have more kind of ways to analyze that data. This application will be included in the next phase of the project. I mean, they also talk about the next phase for the project, which includes expansion across several X product lines to be distributed widely across the United States. I mean, they start just in the western part of the US, but still they want to expand and to extend the system to other countries. I think they already did it. You can check the website and the app in the Google.
Okay.
And thank you for your attention. Thank you so much.
Thank you. I think something I want to reconfirm is actually last time I already showed a video about blockchain technology to, Patrick, Susan, and Esther at that time because Patrick's paper last time also were about blockchain. So, in the part that you explain blockchain technology, the hash, yeah, the hash that you mentioned, it's not the value of the transaction. It is like a fingerprint, an identity code specifically for that transaction in that block.
Yes, I mean, you can put it in many how to say many values, many kind of values. I mean, it could be the block ID, it could be your money ID, it could be your password ID, it could be many things, but it need to be defined before to use it. But the hash will be continue. I mean, for the next block, for example, this block
Yeah, yeah,
ID,
yeah, yeah,
and this will
yeah.
get that previous one.
It has to contain, yes, the previous one. But
Yeah,
this
you get it.
hash is actually the most important one because it would be calculated by those network of those miners.
But do you see the first one? Do you see this hash zero?
Yeah,
Yeah, it means the hash zero means initiation for the
yeah.
previous.
So
There is no
yeah,
previous. Yeah, and when you finish the hash, I mean, when you finish the last one, the last block will have also hash zero.
yeah, they will include all of those, and that is why blockchain improve the security because you cannot hack or you cannot change the information or the hash because once the hash is changed or disrupted, then it will then the next block will not verify its previous block, and so the whole information will not be verified.
Yeah, it's true.
That
It's
is
true.
why
All
it
right.
is, yeah.
Yeah,
That's
because
why it is very
in
secure.
here in this picture we just see the number, right? But actually the hash contain not only the number. It has inside. They have the transaction. They have the
Yeah.
money. They have the
Yes.
time.
Yes.
They have many other attributes. But
Yeah.
but
So
in this example, it's just one number.
yeah, 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 yeah. So that why I want to emphasize this one because this is the thing that it improve. I mean, how to say that contribute to the application of this case study because they are saying that it enhance the integrity of the whole information process because it cannot be easily changed. So basically, it's safer or more reliable for consumers because even those farmers or those in the middle stages, they cannot change the information so that they can fool the consumers in a more preferable ways or in favor of their,
that
benefits.
that's why I put the example here of the Excel sheet because most of the farmers, including in my country, I mean, we all use Excel sheets for I mean for data to store
Yeah,
the
so
data.
it could be easily manipulated, right?
Right, manipulated or alterated, and that's why I put
Yeah.
the comparison with the database, which is it has integrity inside.
Yes, yes, yes. So I think because even in Taiwan now we do have that kind of QR code on the package of the products, and you still can trace some simple information where it has been, when it was collected, blah blah. And those vegetable package in the supermarket, we already have that kind.
Yeah, it's true. It's true. Like for example, now we because the virus COVID-19, we need to go every place and we need to track ourselves with a QR
Yeah,
code.
yeah. Yeah, so that's why I think for this case study, when it's the how say that significant contribution when they want to use blockchain is because those information are collected automatically by even those sensors or those other equipment. So it will be put in the system and it cannot be changed or manipulated by those parties.
Yeah,
So
they
I think
want
that
to.
is the most, yeah.
Yeah, it's true, and they want to do it in each stage of that traceability.
Yeah. And yeah, so that's why I think of course it's not easy to apply because it's you want to run the whole system, then all of those involved parties in the whole process have to agree and use the same interface with you. So I think that's why it's good, but it's hard to apply in real life and not very quick
Yeah,
because it's
they
new.
face in the paper they mentioned they face many problems. Like for example, in
Yes.
Europe, they have a different standards to
Yeah,
implement.
yeah, yeah, yeah,
And
yeah.
and and you can see here. I mean, you can see the real application it still works. I mean, you can find it in in Google. It's a real one.
Yeah.
That's why I really enjoyed that. I mean, reading this paper, and I found the application too on the net. Nice.
Yeah, that's what I mean. I like this kind of paper because it shows a more practical thing or easier to understand.
Yeah,
Because the paper that you presented previously, I only can understand the kind of the general concept and the contribution, but I cannot go deeper because it's too technical.
right, right. This one is also a little bit technical too, a little bit.
A little bit, but as long as we understand the how I say that the advantages that blockchain brings and the core how I say the concept of how it works, then we can link it or relate it to how it benefit this kind of food chain management.
Right, right. It's true.
Yeah, and it's I mean it can be applied more visible to us in our daily use. So that's why I think to me it's easier to understand and easier
They,
to relate to behaviors.
I like the way also in the paper mentioned it, like it's important about the infrastructure because some farmers they
Yes.
didn't have
Yeah.
the infrastructure, so that's why maybe they cannot join it. I mean,
Yes.
for
So
the
that's why I
collection
think
stage.
it's not that easy and it's not that fast for especially in this agriculture industry. It's not that fast for them to apply this kind of system.
Right.
Yeah. Okay. Any questions for this paper for Joseph, Patrick, and Susan?
Yeah, I just want to contribute small and then probably will ask Joseph
Yeah.
with
Yeah.
regards to yeah, some of the products like perishable goods, like tomato, which are not like eggs, because eggs can stay up to 15 or up to one month. But for tomatoes, so mangoes or other more perishable goods, how they can be included in this type of system. Now, okay, we know, like for example, the way blockchain works in the finance world probably will be different with food products because with finance world, you are not dealing directly with tangible goods. They are just mere concepts or figures like Bitcoin, they are not tangible
Yeah.
goods. So more or less like abstract.
Yeah.
So, but now you are really, when we are talking about X, you are dealing with real products that you can hold it with your hand and they need to be moved from one place to another. And all that
Yeah.
we can agree here, how to trace if maybe from the farm to the table where it is being consumed.
Yeah.
So now let's say, for example, if it was like a product like tomato, for example, do you think this application will work?
I think
Joseph?
yeah. I mean that for any kind of product because they mention it. I mean they want to extend also to other products on the farm, so they want
Yeah.
to check about this. I mean the traceability of the standard process they have. For example, the cleaning, the processing, the grinding, the packing, and the distribution. if the tomato can be including in this kind of a standard process, maybe they can start to do a traceability software for each product. I mean, the key point is to have the standard first, and then they can become the standard into a software.
Yeah, I think so. I mean, it can be applied to any kind of food because I mean, of course, each one will have different nature and they have to modify or customize a little bit. But I think the principle is kind of similar.
Yeah, but I mean, even though any kind of soup is possible, but the food in itself should be immersed in a standard process of collection. Like they show in the paper, they have the, for example, they collect the eggs and they have already the time for cleaning, the time for processing, they have the logistics to do the grinding and the packing. But for example, if you collect tomatoes in a farm and this farm, they don't have anyone, I mean, they have any standard process for collection, any standard process for packing, you cannot put any software in this. It will be very, very difficult.
Mm.
It's like, for example, I have
Okay.
my family business. I cannot even though I'm very small company, I cannot put it my a software because it will be troublesome for me. And will be even more expensive like the solution.
Yes, yes.
Yeah.
So that's what I was trying to say, because it is going to be more or less like it will not be cost effective, or maybe in the distribution part there will be more challenges there. Okay, because this one actually you can do it manually, but you cannot be able to inculcate it in your system. However, but with the distribution, because they are perishable goods, probably it will take time before they reach the final consumer. And along the way, probably they can always report about damaged goods or so. So that's what I'm trying to
Yeah. Sure.
put here.
But
Yeah.
because that is that kind of food, then it's even more important to the consumer to chase its origin or its process.
Oh yeah. Yeah. Also, could be possible.
Yeah, but the origin, maybe probably that time it is still fresh, okay, and good to eat. But as it is, as you transport it from one spot to another, it will lose that freshness. So
Yeah,
you will
so
always have
so
consumers.
Yeah. I think yeah that we need to be fresh. Yeah.
Okay.
Another question.
Does that
not for me. I think it's okay. I mean, I'm pretty clear about this paper, and I understand its contribution clearly. So no other questions.
All right. Okay. Thank you so much.
So
And
Susan, any?
No, no.
Okay. Yeah. So I think that's all for this paper. Also, Joseph.
okay. Thank you so much, Professor Mio.
Thank you.
Thank you.
Thank you.
Yeah, very good presentations. I mean, from the two paper, you make it very brief and effective.